In missions 2, 3, and 4, you got to determine the details of how you're going to make a new product, and then produce the planning documents needed to ramp up to full production. Now at Hoosier Racing, we've begun full-scale production of our new line of helmets. So, how are we doing? Are our customers satisfied with our products and services? Are our employees safe? Are we meeting our product and distribution quality standards? Are we keeping our costs in check so the company is profitable? Are we getting the right products to the right customers at the right time? And are we taking good care of the environment? Successful advanced manufacturing and logistics companies continuously measure and analyze their performance in all of these areas. This mission will help you think about what we measure, how we measure, and then analyze our performance and productivity measurements. All of these tasks contribute to the vital work of operations.
No doubt you've been a customer many times in your life. For example, anytime that you bought something at a store or purchased a song over the internet, you were the customer in a supply chain, an external customer. But there's another type of customer too, an internal customer. Any employee of Hoosier Racing who receives a product or a component of a product from another department in Hoosier Racing is an internal customer. In the Logistics module, Mission 3, Individual and Team Effectiveness, you learned about the importance of effective communications with both internal and external customers. In this leg of the mission, you'll see examples of why quality matters to both internal and external customers, and how successful operations management hinges on ensuring quality for both. Read the instructions below, and then click OK to begin.
Click each type of customer to learn more.
Hi, I'm Sheila, and I'm part of the work cell that preps helmet shells for final assembly. Our cell pre-drills the holes that are used to attach the face shield and preps the inside of the shell for padding. A while back, our internal customer, the Finally Assembly cells, had a problem with the face shields fitting in the pre-drilled holes in the helmet shells. I knew that those face shields had to fit correctly to protect our race car drivers, so I couldn't ignore the problem. We immediately formed a team that included the face shield technicians to figure out why the holes weren't lining up. Shortly, the team had the problem corrected and put measures in place to prevent it from happening again. By treating my coworkers as my customer, we were motivated to identify the problem and create a solution. There's no way I'd pass a problem on to an external customer, so why would I pass one on to an internal one? Treating coworkers in other departments like internal customers really works to improve quality and performance.
Hi, I'm Jimmy Joe Crawford, and I'm living proof that Hoosier Racing helmets have the best quality around. 2 years ago, when I was in this crash, I was wearing a helmet made by Hoosier Racing. The helmet didn't survive, but I did. The helmet did exactly what it was supposed to do. It absorbed the impact so that my head wasn't harmed. The doctor said if I wasn't wearing that helmet, I wouldn't be here today. So I just wanted to take the time to tell everyone there at Hoosier Racing that every minute you spend designing quality helmets, building them to precise specifications, and testing them to make sure the quality is top-notch is time well spent, because we put our lives in your hands. So to everyone at Hoosier Racing, thank you for caring about quality. I thank you, and my family thanks you.
Many things can determine if a manufacturing or logistics company wins in a financial sense, but there are 5 major operational elements that influence success. By now, you can probably guess what they are because we've been learning about them through higher technology: safety, quality, cost, delivery, and the environment. So why do we keep coming back to these? Because they drive industry operations and the bottom line. This may sound simple, but a lot of thought, planning, and teamwork go into continuously improving performance related to these elements. In this leg of the mission, you'll learn about each element. Read the instructions below, and then click OK to begin.
Click each element to learn more. The most important measurement of operational success in advanced manufacturing and logistics is safety. You can measure safety for the company and for yourself every minute of every day by considering these questions. Were there any accidents? Did anybody get hurt? What did I do to make the workplace safe and healthy? What did I do to ensure a coworker remained safe? Did I prepare products so that our workers and customers remain safe when handling or using them? The bottom line is that without safe and healthy employees, there simply is no product. A company's very existence is based on its ability to deliver quality products that exceed the customer's expectations. You can measure quality for your company and for yourself each day by asking these questions. Did I make sure the products I produced met the required specifications? Did I solve a problem that improved the quality of our products? Did I make sure the products were packaged or prepared appropriately? Did I ensure products arrived as expected and on time? When we talk about costs, there's a lot to consider. All manufacturing companies know how much a product should cost to make. This is known as the target cost, which is determined during the product design phase. Whether or not the target cost is met instantly becomes a measure of success. Meet it, you win. Miss it, you don't. Pretty easy concept, right? Advanced manufacturing companies need to know their cost of production to determine if they're meeting the target cost. Complex software systems gather information from the production and the quality system hardware and analyze it to determine the cost of production. The cost of production is measured against the target cost in 2 ways. First, we look at quantity, the number of products that are made every minute, every hour, every day, and every month. Then we look at quality and try to find out if any products didn't meet the necessary quality standards. Cost is a big deal in logistics too. There is so much to consider: freight, distribution center labor, distribution center charges, inventory, and of course transportation. So we use cost containment strategies, which means following certain rules to make sure costs stay in line. This helps with our profit and prevents us from wasting time and money. Delivering products on time is a win for the company because it's how the company generates revenue. In logistics, delivering products safely and on time is a win for the company because that's pretty much our main purpose. We create the plan for delivery and then make it happen. Products should continuously flow, not just move and wait, and then move from or between vendors and customers. What exactly does safety mean in terms of delivery? Simply put, it means making sure the product is damage-free and works properly upon arrival. A winning delivery team includes vendors, carriers, and distribution center employees. A company's environmental policies can have a huge impact on its winning percentage. The environmental win is also tied directly to quality, cost, and delivery. When we produce poor quality products, we have to scrap them, which is a waste of resources. Resources like raw materials and electricity, both of which have environmental impacts. In the same way, a major delivery expense is fuel. So the better we do at getting our products to our customers efficiently, the more fuel we save. So if we're doing a good job on quality and a good job on delivery, then we're most likely also meeting our target cost. After all, fewer materials and less fuel means lower costs. In short, if a product meets quality standards and is delivered on time and at the target cost, then the company consumed less energy and fewer natural resources during manufacturing and delivery and created less waste overall. And that's a win for everyone, including the environment.
As a student, your performance is frequently measured by scores on papers, projects, quizzes, and tests. If your scores aren't where you know they should be, you make adjustments. Successful advanced manufacturing and logistics companies also frequently measure and keep score on their performance. And like you, if their scores aren't where they should be, operations makes adjustments and improvements to raise company scores. In this leg of the mission, you'll learn about common measurements and statistics used by advanced manufacturing and logistics companies to keep their operations successful. Read the instructions below and then click OK to begin.
How do we know if a work cell is not producing the number of products that we expect? By measuring productivity. If your employees or machines aren't working productively, then you may need to make adjustments. In Unit 1, you learned how to calculate employee productivity and machine productivity using these formulas. Let's review one example of employee productivity. Sue takes half an hour to assemble one helmet. She produced 12 helmets in 8 hours. Sue's productivity is 75%. If she was only making helmets in those 8 hours, that is not very productive, and adjustments may be needed to increase her productivity. Our distribution center isn't making products, so we have to measure their productivity using different measures. Some common distribution center measurements are the number of cases per hour, number of pallets per hour, line items of orders filled per hour, the cost of labor per case, or the orders filled per hour. Hoosier Racing figures that our customers care more about getting their order filled quickly, so we measure the orders filled per hour. Yesterday, we filled 2,000 orders using several employees who worked a total of 16 hours. Their orders filled per hour is 125. How can we measure the productivity of our transportation group? Different companies use different measures such as the cartons delivered per mile traveled or the cost per carton delivered. Other companies measure the percentage of shipments delivered on time or the percentage of the shipping container being used. Hoosier Racing figures that customers care more about getting their package on time, so we've decided that our key transportation measure is the percentage of shipments delivered on time. Our goal is to have 95% of all packages delivered on time. Did we make our goal for January and February? In a previous mission, we learned that capacity measures how much we can potentially produce with our available workers, machines, and facilities. Capacity utilization helps measure how much of that potential production we're actually using. To calculate it, we just take the amount of goods actually produced divided by the total amount that we're capable of producing. At Hoosier Racing, we are planning to launch a new line of fire suits next year and are creating the planning documents needed to have a successful launch. Currently, we are producing 375 fire suits per month. We have the capacity to make 500 fire suits per month. What is our current employee capacity utilization? In supply chain management, velocity means the speed of all transactions within a supply chain. The higher the number, the better. Let's look at two types of velocity measurements. Process velocity measures the speed of the process. The faster the pace, the better, because it means we can create more goods during a given period of time. The reason that's important is because we have lots of money tied up in things like raw materials. The way that we get that money back and make a profit is by converting those raw materials into goods that we can sell. It's like this. Not many people would want to buy fiberglass sheets and resin, but when we take those things and use them to make a racing helmet that people want to buy, we've managed to turn raw materials into money. And the faster we do that, the more money we have to pay our wages and bonuses. Inventory velocity is the speed that inventory passes through an organization or supply chain at a given point in time. It's measured by inventory turnover. Click Inventory Turnover on our scoreboard to learn more. Inventory turnover is the number of times that inventory cycles or turns over during the year. The higher the number, the better. A way to calculate inventory is to divide the average cost of the inventory into the annual cost of sales. For example, an average inventory of $3 million divided into an annual cost of sales of $21 million means that inventory turned over 7 times. We've been talking a lot about productivity and how quickly and efficiently we can make and move things. But you know what? None of that really matters if we're not producing and delivering quality products. If we ship bad products or the wrong products to our customers in a hurry, then they're just going to send them back to us in a hurry and possibly never do business with us again. And no company can survive without satisfied customers. The demand for high quality comes from customers and manufacturers alike. Manufacturers demand that suppliers provide them with defect-free parts, and customers demand satisfaction with their products. A key measure of quality is the number of defects which result in rework or scrap. Rework means that the defect can be fixed so the product can be saved. Scrap means that the product cannot be used. An extremely high quality goal is called 6 Sigma, which equals 3.4 defects per million. You'll learn more about how companies work towards the goal of 6 Sigma in the next operations mission. Another key measure of quality is the dollars scrapped in production. Click Scrap to learn more. The most used measurement of quality is scrap. High levels of scrap indicate defective processes. Defective processes produce defective products. Defective products result in rework or bad products reaching the customer. Dollars scrapped includes the material cost and the labor cost wasted on a defective part. For example, a company scraps $10,000 of material and labor due to defects. Divide that by a total cost of sales of $2 million. That equals a scrap rate of 0.5%. Customer's response time refers to how quickly we respond to a customer's order. A key measure of customer response is order cycle time, also known as the order-to-delivery cycle. It's the amount of time it takes to process an order. It starts when the customer places an order and ends when the customer receives the order. Tracking this number and keeping it as low as possible helps us maintain customer loyalty. For example, a customer places an order on January 5th at 1 p.m. They receive the order on January 8th at 4 p.m. The order cycle time is 3 days and 3 hours.
It's really hard for most people to see patterns or trends from a whole bunch of numbers. It's much easier to use charts and graphs to identify patterns and trends or even uncover potential problems. Operations uses a variety of great charting and graphing tools to help identify processes and recognize possible problems. In this leg of the mission, you'll learn about some of the tools we use. Read the instructions below and then click OK to begin.
Can you look at this information and easily compare and contrast the production in the different work cells? Compare the table of numbers to a graph of those same numbers. For most people, it is easier to use the graph to answer questions such as, which cell produced the most product? Which cells are trending up or trending down? Many companies use charts and graphs to tell the story of how they are doing or what they are doing. Let's take a look at 5 types of charts and graphs that are commonly used by operations in advanced manufacturing and logistics companies to tell their story. A flow chart is a great tool to illustrate a process. A company might use a flow chart to teach a process to an employee. They might also use flowcharts to find bottlenecks or problems with a process. This flowchart shows the process of a product moving through the paint operation. Depending on the nature of the process, there are standard shapes to depict the flowchart inputs, outputs, operations, decisions, and other actions. Typically, rectangles represent process steps. Diamonds represent decisions. And ovals represent the start and end points of the process. The start and end points are also known as terminators. The input to the process is receive part, and the output is package. After the part is received, it is painted. Then a decision must be made as to whether or not the part is acceptable. If it is, then it is packaged. In this case, the accept decision would be based on the quality of the paint job. Remember, only products that meet our high quality standards should be sent to our customers. A cause and effect diagram, also known as a fishbone diagram, is a common tool used to troubleshoot problems. Fishbones aren't just choking hazards. The example shown here was created by a Hoosier Racing team that is trying to solve a packaging problem. A cause and effect diagram lists causes and subcauses that are contributing to the problem. The diagram organizes possible causes of an issue into 6 main causes, or bones. Materials, machine, people, method, environment, measurement. For each cause, the diagram lists possible subcauses for the problem. Review the diagram and then click on one of the reasons of how people could cause poor packaging. A control chart is a tool used to determine if your process is in control. That is, are your measures within an acceptable range? Control charts are a common way to visualize and measure variations in process. For example, control charts can be used to measure product quality standards over time. The top line is the upper control limit. It shows the topmost measurement that a data point can have and still be in control. Similarly, the bottom line is the lower control limit. For a process to be in control, a data point cannot dip below that line. Process data and your process goals are used to determine where these upper and lower control limits should be drawn. The center line is usually the mathematical average of all the samples plotted on the graph. Looking at the chart, is this process under control? As long as product quality standards stay within control limits, the process is seen as being under control. However, in some organizations, control data may still be evaluated for trends, even if the process is within limits. For example, If measurements go above the average for 3 months in a row, the company may choose to investigate the root cause. Another type of control chart commonly used is a scatter plot. Each dot on the scatter plot represents an XY pair of data points. In this case, the X value represents a day of the month and the Y value represents number of goods packaged on that day. A scatter plot is commonly used to see if there is a relationship between the X and the Y by looking for trends. In this example, there is a strong trend to package more items as the month progresses. A histogram is a common tool for analyzing categories or buckets of different types of problems. A histogram plots a measurement scale on the y-axis and types of data measured on the x-axis. Yep, you're right, it's just a bar graph. In this example, we want to analyze packaging defects. We've found there are 3 major kinds of packaging defects: items that are broken, packages that are labeled with the wrong lot number, or packages that are dented. The histogram shown here illustrates how frequently each type of packaging defects occurred. The y-axis shows the percentage of packages that were defective. In this example, which type of defect was most common? Respond by clicking on the graph. Which type of defect was least common? Respond by clicking on the graph. A Pareto chart is a special type of histogram where each category is ranked from highest to lowest frequency. Right again. Pareto chart is a fancy name for a column graph where data is placed in order. A Pareto chart helps you more easily identify the most common problems. Although a company might like to solve all problems, most companies do not have enough people, time, and money to do that. The theory of Pareto analysis is that about 80% of the defective work comes from 20% of the causes. A Pareto chart helps us to focus on the best use of resources to get the greatest gains. Where do you think this company should focus its efforts to reduce complaints? Remember, you want to work on the root causes that account for around 80% of the defects. Select one or more items and then click Check Answer.
Congratulations! You have completed the Measuring and Analyzing Operations Performance mission. You should now have an understanding of internal and external customer requirements, the main operational elements that can help a company win, methods for measuring company performance and productivity, and basic chart and graph reading skills.
One of our plants makes parts for motocross motorcycles. You're part of the operations team that's looking for ways to improve some quality issues that they've been experiencing. In this leg of the mission, you'll help them choose the right quality control tool. Read the instructions below and then click OK to begin.